Hello, and welcome to this lecture on our arithmetic operators and the calculations that go with those within our attribute setup. Now, let's look at this as probably one of the probably one of the largest. Let me have a think. No, this is the largest class we're going to make. Now, I would say that a job for you. I put all the functionality back into this as this was version 4 of my nodal system. I'm on version 12 now, although I'm working with companies with it, so I don't want to obviously give away too much of my knowledge or my recent updates. But this nodal system isn't as clean as it could be, but I think that a good job for everyone on here, that as you're going through this, you'll probably be able to see areas where you can actually abstract some of the complexity even further and actually even modularize some of the complexity. So you can take out maybe some of the multiply divide node or some of the creators, or even do what we did with our attribute condition, where we essentially make another class inherited from our dep node, which then gives it all that ability just to be able to create a condition, but also then have access to quite a lot of functionality. So for example, you might want to put input x1 and input x2 as your arguments, because these are what are essentially going to be set by yourself. You might want to then also have maybe a double linear. You may want to have a ramp node. These are just some suggestions which may or may not have been things that I've done with my current system. Well, yeah, they are. But yeah, they're a really good training method, again, for you to be able to write your own kind of setups and then move them a bit more forward. So, but with this next bit of functionality with our arithmetic operators, essentially what we are going to do is put everything within our attribute base, mainly just because I don't know if I've said, but my wife is actually due to have her baby in the next 2 weeks. And it's been 6 months of me keep on putting this off. And so I'm trying to find evenings essentially where I can get this done before the arrival of my second child, which obviously is going to be an incredibly powerful and emotional experience. And I don't really want to take it up by being then on my computer after. I'm going to try and switch off a little bit if I can. Obviously, I'll still be working in my period after that, but I don't want to then be doing extra work in my own hours where my family's sleeping. I want to actually try and sleep myself so that I have the best quality time with them. So let's, without ado, let's get started. Let's cycle down or scroll down right to the end of our comparison operators. We'll copy this divider. Let's duplicate it, add it just above, and we're going to add all of our new functionality in here. Now, a first bit of functionality which I kind of realized I'd forgotten was actually 2 properties, and they were, I'll add another divider. And we're going to need them quite a bit here. So we're actually going to call these, these are 2 properties, and they are is parent and is child. And I'll write these out now for you. Okay, perfect. So we've got our two new properties, essentially is parent and is child. And these are essentially getting us the Boolean response from is parent. So if we get a response from parent of an empty list, then obviously that will essentially just give us the Boolean response of false. And the same for child. Empty list, false, full list, true. Anything with content, essentially the Boolean operator will state as true. So we're going to add these in here. And now let's scroll up, because we want to, so essentially why we're doing this, we want to be able to ask, is an item a parent or a child? And then be able to essentially correspond that with items that we're plugging into. But anyway, let's quickly jump up and get to our operators. So what we want to do, let's type up here. We're essentially looking at making our operators for plus, minus, divide, times, and also power. But obviously we want also to be back compatible, so we're going to have a little bit of functionality to make sure that that is the case. It's very simple actually to make sure that this section is back compatible. But let's get started with these operators. Okay, so we have our operators here, which we're going to use. We're going to need a lot of functionality with these, but these are our operators, which are essentially going to do quite a lot of awesome things for us. They will allow us to essentially piggyback on the arithmetic functions of Python and then create nodes accordingly, which when we're creating some complex setups and we want multiplications and divides to happen at certain times within certain parts of certain attributes, then we can quite easily write Pythonically or write a bit more in plain English what's happening in the scene, rather than writing a huge amount of code which points all over the place. It has to import 100 modules. We can quite simply just write that in a few lines of code. So now let's start off with add. Okay, and for this node, we are going to be using the plus minus node for the connections. An example here is essentially, this would be like similar to calc or ASLIC. Or calc, here we go, node.a.sx plus node.a.sy. And then from that, essentially what you'll be able to do is then also go plus node.a.ty. And then from this, so you can essentially then have much longer and longer equations, which again are still very readable, or very much more readable than they would be if they were not in this type of system. As far as I know, I think this is the most, or probably the easiest way that you can get these kind of multiplications to be readable, or these type of math operations to be readable. So let's move on then. Okay, and say, okay, so the value is going to be what is passed. So as we said, it can either be plus that, or it even could just be a string, because obviously the function that is using the operator is the class. So as long as the class is first, then you'll be able to add another attribute to it, another value to it. You could just add one, and then that would add that to it and give you the output calculation. You'll be able to do whatever you need to as long as you start the calculation with the class. Okay, and now let's look at creating our plus minus average node. Perfect, so here is our string for this. Now this is the plus minus average node. This isn't where we're going to create the node, but we're going to decide what we do here. So essentially we're adding or subtracting the value passed or attribute. Okay, and so this will either add to a current node, or this will essentially create a new node. So it's a little bit, this is where it starts getting complex, because we're dealing with such a crazy hierarchy of where you could do multiple equations. We need to be able to handle that. We're handling the situations where we are either essentially creating a new node to work with and plugging into it. We are adding to a current node. So let's go out and run our functionality out down here. Okay, perfect. Let's quickly go through. So what you can pass here is either a value or an operation type. The value is either an int, float, a string, or an attribute object, essentially the value to use. And then we have the operation type. The default is number 1, which is the sum type. We have the operation type number 2, which is subtract, operation type 3, which is average. And this then returns self. So it returns the calculation that has been completed on the operation. And then this returns essentially the object itself. Okay, so an example would be, you got the add node or the calc node, and you would just go attribute scale x plus attribute scale y. And then you can either grab that as a calculation, as you can see here, we're getting into a long chain, or you can, and then you can grab that calculation and then go calculation, output, and straight into our scale x, or a scale x of an item, for example, or any attribute. Okay, and pause here and copy if you need to. But what we are doing here is we are getting the node type, which is plus minus average. We're then passing that through to create a node name, which is a functionality we will create in a second. And we are then getting our name that we need. And then we are deciding, and we are going to look at whether this attribute is essentially a parent or a child attribute. So you see 1D or 3D. Essentially, if it's 3D, it's three-dimensional. There are three children under it. Or is this one-dimensional? Is this one-dimensional item, a child? And then from that, we are then going to make the addition to a current plus or minus node if that is self. So if what this attribute is a plus or minus node, then we are essentially going to plug into it. So we're checking if the node type is a plus or minus node, or we are essentially then going to essentially check that the operation is the operation type we have, and if it is, and all of those align, we are just going to add to this node. But if not, then what we are going to do is create the new node and return that, which is essentially going to be create a new plus or minus average node, which we could just say create plus or minus average node, or create plus or minus. But yeah, we'll change that actually. I'll do that now. Yeah, so that I think is everything that we have here. So let me just see where we need to go next. I'll see what's best to do next. Okay, so let's create these functions that we see here. We've got create node name. I'm going to do Control-Shift-Alt. Highlight these items. Okay, so we've got 4 new functions to make here. And let's put them down here. So let's go paste. We're going to double tap Control and press up. And then we're going to go to the beginning of the line with FN and left click, or I think Command, left tap, sorry, on the mouse, on the keyboard. And then we're going to go, open a bracket, and then we'll just put pass at the end. So all these are being used already, but we don't want the red. So now we see everything has gone out from being highlighted. And essentially doesn't return anything. Oh, exactly. So we haven't filled this in yet. It's saying we can't actually get a node name because this function doesn't seem to return anything. And of course it doesn't. That's because we haven't told it to yet. So let's do that now. So create node name. Let's keep a nice simple doc string for this because I think like it does explain itself. Okay, so what we're doing here is we've got our 2 positional arguments, which are value and suffix, which we can see here. So value is the value that is passed. Again, that can be any of these items. It can be an int, float, string, or an object. And then we also are passing the node type, which we are saying is the suffix. And we're going to get the first index item in that string, so the P. And then we're going to join the list of items of all that are upper, essentially, and then set them to lower. And that is creating us our suffix of PMA, which we'd actually, I think, prefer all to be upper. So what we're going to do is go upper, and then upper. What I would say is, again, you should have this in a common naming module in a dictionary, so you can search, say, this is the node I'm creating, what should my suffix be, and then you can just return that back. But the minute we're just going to create it all locally. Now let's do a bit. Okay, brilliant. So we've got our suffix cut. We are going to pass that through. And we see we're going to essentially add it into a string of these 4 items. So we've got 1, 2, 3, 4. Okay, at these different index points. We're going to have the node name. We're going to have the attr and the value, which again could be any item, but the string will be forced. Okay, so through the format. So if it is an object, that is where we're going to return the string and use that. If it is an integer or a float, the decimal will be removed, but it will still just retain most of the numbering information from it, and then the name will essentially just be joined together, and we will remove okay, here we go, non-string punctuation. So anything that is a string punctuation, we need to import string, will then be joined together and using this. Now let's go and do a little example somewhere where it won't actually bug out because we're not importing my commands. Brilliant. Right, we should do it here. So let's go import string. And we will print string dot punctuation. Sting. No. And we'll go and press play. And awesome. You see, we got out all of our information. On test run. Okay, perfect. So any items that are found in here that essentially are not string items, they are going to be switched out for what we know that my can accept, which is this item here, the underscore. Perfect. String has a lot of lovely little features like that, but let's remove that for now. Put the path back. Go back down to where we were. And then we are going to return node name. Our second item will essentially just check the connection attribute with the current class instance. So we are going to check whether the connections are both parent plugs or children. And to do that, we are going to use this little bit of code here. Okay, so what we're going to look at is essentially the input, which we shouldn't be using. That's my bad. I've just used input, but that is a keyword, so we do not want to use that. We'll put input value, actually. That'll get a little bit better. So let's say input. What we're going to do is we're going to return true if isInstance of our attribute and input value dot query is child, or we could even just say is child and save ourselves that little bit there. So this will essentially check if it is a child, and then we're going to correspond that true or false output with the true or false of the class instance we have, which is this class instance a child. So we'll say, is this a child? And if it is a child, okay, and this is a child, then that's perfect. That's exactly what we want. Okay, perfect. All right, that's good. Now we've got add to plus or minus or create plus or minus average. So yeah, these two again are the main kind of chunks that we need for quite a few of our setups here. But let's go through and write our docstring for them. And so, as I said earlier, we're essentially either looking to create or add to a plus minus average, depending on the input that is given. And so what we're getting here is we're getting attribute and value. What am I doing? So attribute and value here. Now, again, these can be any of these objects, which is what makes it a little bit more complicated. But what we want to do is essentially now add to the current node that we have. So let's get that. Cool. Perfect. So there we go. So you'll see we're not returning anything here. And that is because when we do our add to plus or minus, we're not actually creating anything, but we are just adding to our instance of ourself already. So we just then need to return self. So if we go back down, what we'll see is we're getting our connection index. So what we're doing is we're getting the atta of self.node attribute. And what we want to do is try and see where we are connected, essentially in this plus minus average, because there will be a list of input connections, which you can see when you test this. And we're trying to then see what point we are at, because that connection index point is what we then need to put into our string. And we're obviously using our dunder method again, get item, because we don't exactly know what we're going to be getting. Life is like a box of chocolates. But we do see here that we need to be able to kind of get our attribute and then also use the Pythonic, or well, use the Maya kind of string appendation way to get items. So they must be doing something like this in the background, essentially, within the Autodesk Maya setup. But this is why we need to kind of do this little connection here. So we've got our attribute which is being passed. So we've got that, and we can put that string right in there. And then we also have our connection index. And then from that, if the value is an int or a float, we are just going to set the value. But if the value is not, then we are going to essentially just connect to it. So we are essentially going to force the connection going in with the value going in from the right shift connection. Okay, perfect. Now, okay, so that's the adding to the one that already exists. Now let's create plus minus average for an item that we need to let's create a new plus minus average for a new arithmetic that has been placed or created. And what we have is all of our inputs here. And what we can do to make them a little bit more readable, kind of going out, we can do that. And that gives them a little bit more of a line by line kind of, okay, this is what we've got. Self, which is the instance of the class itself, node name, node type, operation type, attribute, and value. And what we're going to do here is create the new plug and make the connections to the node. So we've got our node name, which is a string, node type, string, operation type, int, attribute type, string, but the value that we're inputting, we are not sure. It could be any of these, so we're going to check for that as we go through it. And this will return you, essentially, a class of what we're using. Depending on if you've encapsulated whatever you're getting it with, it could return a string, but well, it won't return a string, it'll be turned into a string. But this will be returning the class, the attribute, nodal name, and class to be specific. So you'll see our 6 string types again. So let's firstly go upstairs, up here, up the top of our code, and add that import. And now what are we looking at here? So great, firstly, we're using the import of dep node. Again, we are importing a dep node. We cannot import dep node at the base level because we are in the dep node importing the attributes from attribute base. So you'll get, again, an import error. But what we are going to then do is use our dep node here to create use our node name, which was passed, and our node type to create a plus minus average node. Okay. And then we are going to set the operation here using the node, the attribute connection, operation, and set that we are now creating within our attribute setup. Then we are going to connect the original item into the node. So plus minus average dot attribute, and then the get item, the attribute then being plugged into, okay, with self. And then we are going to check if we have a float or if we have any strings. So we are going to first say, well, if the value that we're plugging in to self is or going to be plus minus dividing, doing an operation against our self instance is either a float or an int, then, okay, we will plug into it going this way, add to plus minus average that we've just made. So we've already made our plus minus average node here. We will then essentially add to it with the attribute and value that we have, because we have already created it, and this is the logic to add to it. It's brilliant. Okay, but if the instance is just a string, if it's just literally any random piece of information, or if the instance is an attribute, then all we have to do essentially is connect to it. So what we'll do is input and connect, and that essentially will then just connect to the attribute in the right index, or in the correct index of where the attribute needs to be connected to. Perfect. Okay, and then we will also check the connection attribute that we just made. Make sure that they are both, okay, if they are both children, if they are both parents, we output the parent node, but if not, then we will output child node. So again, this should return true. Let's have a quick look again. So true. If instance parent is child, then that should be true. I think we're doing this the wrong way around. Let me change this, and we'll check this within our tests later. Again, I've done a little bit of reformatting so that we can essentially get all the code in here. But I'm pretty sure some of it will run correctly. If not, we will fix it in our test, which is what tests are for. Okay, perfect. So we'll scroll back down. So we're now saying, well, yeah, if both of these items are parents, then we are literally going to return the parent item. And if not, we will return a 1D, so one-dimensional part, the one-dimensional output, sorry, which has all of those items added up underneath it. If not, just the 3D output, which again is the parent. So perfect. Or takes input of parents, I should say, and then outputs them in that fashion. Perfect. Okay, great. Okay, so now we are going to scroll back up. That is our very first, that's quite a big chunk of the code that we need to write here. So where we're going to go here is back to our arithmetic operators. What I'm going to do here is I'm going to do a little thing which I remember Kimon Matara showed me, and it was a really great little technique, and it was just doing 3 hashes. This guy is so much smarter than this. It's not the only thing I took from him, but essentially doing this kind of little 3 hashes and 1, 2, 3, and it makes it very easy just to search for any point within our code. Okay, but we are going to again write out this little bit of code here that we've just done. And what we are going to do here is now use the exact same plus or minus average node, pass the value, but with the operation type now being 2, because as we saw below, the operation type of 2 is subtract. Okay, so if we go back up, we are now ready to already do add and subtract. Okay, we've already covered that functionality. Brilliant, right? That is pretty cool. All right, and now we will go down to the multiply and divide, which will have to be new nodes. These are essentially going to be multiply divide nodes. So we are going to try, we'll probably end up using the same bit of code for these as well. So what we're going to do is just write out the string for divide, and we can copy that over to true divide actually, because, actually, sorry, multiply, I've missed, what am I doing? Here we go. So multiply divide node. Let's go up here to this. Let's write the string. So here we want to be able to use the times operator, essentially the star, which will be able to times one node, one attribute node by another. Okay, brilliant. Now that's a little bit of code for calling. And now let's go and create that function. Okay, and let's go ahead and create this. And here is our string. So this is going to be used for multiplying or dividing the value passed or attribute passed. So the args, we've got value, which is string int float, and the value to you, which is the value to use and drive, and we've got the operation type, which is int. And essentially we've got operation type 1, which is multiply, 2 divide, and 3, which is power. Okay, and this returns the created node, which is an object. Example 1. Here we go. We could say an add node, which is actually incorrect. That's me copying code badly. So we could go multiply. So here's our example here. Okay, perfect. So we have everything that we need within our docstring to make it a bit obvious. Let's scroll down and have a little look at the code, which is a bit more, it's a big section because again, we're doing quite a bit here, but let's have a quick look. Okay, perfect. So we've got our node type here, which again, we are going to use our create node name to give us the name that we are going to use, which has got value and node type. And then we are essentially going to create this multiply divide node down here, depending on what we want to use for it. So let's say so again, if parent, we should probably put that in brackets. And we can do again here, child. Then we will connect basically under these parameters here. And this will be if operation type is operation type 1 or multiply. So we're kind of checking through again, firstly with multiply. Actually, no, I like the space there, it makes it nice and readable. Okay, so we've got our check. So check connection attribute, which again, we are checking. Should probably, maybe that could be check connection alignment. It's probably, again, based on what your preference is there. So if they are parents, which we are checking there with both the instance of self and the value, which is an instance of attribute, of an attribute class, will again return us true for being a parent, for it being a parent. And then we're going to go through to this create multiply divide node, which we haven't made yet. But if it's a child, we can use a create multi-double linear node, which again, we haven't created either of these, but they will then do what we need to. Create multiply divide, again, good with parents because it's got the input 1x, y, and z. And with double linears, again, they just take a list of items. But okay, let's move on to the next part of this code. So if we are dividing, which is operation type 2, so then what we are going to do, essentially, or well, I should say, this is actually passing the operation type. So create divide parent, create divide children. What we're actually going to do here is also check for whether it's divide or power, I should say. And firstly, we're going to check the connection attribute for being a parent. Okay, exactly, there we go. So we've got our 4 new classes we need to make here. Let's copy these, well, 3, 4, there we go. So again, let's copy all of those out that we've just copied. And we are going to then double tap on Control, press the up arrow. And then hopefully PyCharm will wake up. We'll press the Control left arrow to go to the beginning. Press def. And then we will press the Control right arrow to go to the end. Open up the self. And then at the end, press, type pass, just so we don't get too much red. And then add a space in for them as well. Let's start off with our create, multiply, divide, which is again a nice and simple one. Our inputs need to be as follows, or positional arguments, because they're basically only going to be used in this within this class, but we won't do the underscore just because this is such a big class at the moment. It doesn't seem useful. We won't be using these essentially outside of the arithmetic operators. Therefore, at the moment, we just don't need to add that as a thought process. And here is our string. So create the multiply divide node that we will need to work with. Okay, and this takes the args of node name, suffix, operation type, and value, which again can be any of these objects. Is interesting. I've done an open or close parenthesis instead of a J. Great. Okay, and the value to use returns. Okay, a string or class. It doesn't return a string, it returns a class. My head is going tonight very quickly, so sorry. So this is the attribute nodal class. The name you can get quite easily again by going self always. So your class instance dot name. So easy. But now let's add the code here. And here we go. So again, we're importing our dep node because we're going to default create it using the name passed and the suffix. And then we are going to set the operation as the operation type passed. And then we're going to plug into it. So we're going to plug in from self into the input 1. And into input 2, we're going to plug in value because we are assuming that this create, multiply, divide node is a parent. So these will be parent items that can go into input 1 rather than input 1x, y, and z. We're just going to make sure we go into the parent attribute, which is input 1. And then we are going to return the multiply divide output, which again, we probably should name without abbreviating. I've already said that we shouldn't do that. Even though it's in such a small function, it would be best practice. So multiply divide node. I don't know if that's more readable. Actually, let's go back. I don't think it's more readable. MD is just nice and short and sweet. I think, again, human brain needs less information to look at to be able to chunk information well. So here we go. Perfect. Okay, there we go. There is our create, multiply, divide, which is already looking happy up here, not with a yellow highlight. Now let's go down to create multi-double linear, which again takes children attributes, so it takes the child of an attribute. And here is our string. So this is going to create, I should say it's not new, of course, they're all going to be new. Create a multi-double linear node to work with. Okay, this takes the node name, which is string, and then it can take, and again, any of these items to plug into, which will be being checked by some of the classes in the subclass is essentially below this. That'll be the logic that handles a lot of this craziness for us. Here we go. Let's write this code out. Let's import our DAG node again. Okay, perfect. Oh, and I don't know if I just showed that because I've just fast forwarded this. We had the pass after the create multiply double linear, which was making everything look angry. But yeah, you'll just need to remove that. Okay, and we also need to just add in our positional arguments. So let's do that. There we go. Add a little space. And then what are we doing here? Again, we're importing our dep node, multi-double linear, which again, let's see if that's more readable just with MDL. Oh, I like it more. I don't know, this is again your call, but I'm liking that a lot more. It's so much more readable. Okay, we are then using the dep node and creating it because we have the node type. Let's actually check that. I think that might be a typo. Let's have a quick check. Okay, let's open up our Maya and let's do a quick check. So we don't need to zoom in on all this, but it will annoy me. You can't see it. I'm so sorry. But what we're going to actually open up is our node editor. And what we're going to do is type in, is go tab, and then we're going to go mult. Oh, it is mult double linear. It's not multi double linear. Okay, my mistake. For some reason that just looked wrong in my head, but okay, it's because I've abstracted it, so I don't hardly ever have to actually type it anywhere. So here we go. What are we doing? We're creating our multiply double linear node. We're then saying with input 1, just add self. Okay, because we're creating a new one, so we don't need to get the index point or do anything to flash. We just need to input it. And so we are either going to say, well, if the instance is an int or a float, if the value is instance of float or int, then we are essentially, for input 2, we are just going to set the value. And then for input 2, essentially, if it's not, we are just going to, again, pipe it in. Not pipe it in, but we are going to use our connect functionality to just plug that to plug it in to that item, okay, to input 2. Perfect. Okay. Now our last 2, and then we are flying. We are nearly done then. Okay, great job. So we've got now create divide parent and create divide children, okay, to take care of these 2 cases. Perfect. Okay, so first thing we need to do, I've written that text in the wrong one. Let's copy that, or Control X, and then we're going to delete the pass, and then create divide parent. And here we are going to create the multi-divide node to work with parent attributes. And this is going to take the positional arguments of node name, suffix, operation type, and value, and return us. Okay, we should have 1 usage. Yeah, there we go. Perfect. I'll copy down actually all of these arguments. Just get them all ready. Okay, so what are we going to do here? So we are going to create the multi-divide node to work with parent attributes. And this is going to take the node name, suffix, and it is going to take the operation type value, and it returns a class. Great, so let's have a look at our code now. Okay, perfect. So what have we got here? Well, again, we're importing our dep node. We're going to create a node using that with the suffix. Essentially, probably not the best naming, actually. The suffix is actually the node type. So we'll put that down as, we'll change that to node type. And then we've got the operation type, which we'll set by saying multiply dot attribute dot operation dot set. Then we will connect self into this new attribute 1. So the parent attribute is going to be connected to self, because we're assuming that this attribute we're working with at the minute is self.scale, self.translate, self.rotate, or a parent essentially of an output node. So it'll be just the output, not output X, not the output 1D, it'll be output 3D, for example. Okay, and then to connect the value, we're essentially going to check and see if the value is a float or an int. And if it is, we are essentially going to set output 2 to the value, because that will set all of those child objects of the parent to that value. And if not, we are going to then plug them all in, essentially using the connect. And we're going to plug them all in to the multiply divide node right here. Okay, so going into the input 2, we're just going to point a value and set them right in using the operation, or using the operator left shift. And then we're going to reply and return the output node itself. So the parent output node. Perfect. Okay, so what we're going to do essentially for the child item is copy this code here and just copy it down. So we're now going to test change the docstring to work with child attributes. Oh no, machine's going slow again. Oh my lord. Okay, and then what we are going to say is check all of the items input are the same. Okay, we're not working with suffix. We've got everything that is set up the same. Perfect. And we now need to just go through and check everything that we're working with. So we've got the operation type, which will be set. Got the node name. We've got the node type. Okay, and now we need to check the order that everything is being input. So where we were inputting into 1 before the parent, we now need to input into 1 and uppercase X. And that is what we need to input self into. And next, we then need to scroll down a little bit and check that essentially, again, if the instance of the value that is being passed is a float or an int, what we are going to do is pass it into 2x and then set that value. So we're going to set that as being 2x, we're going to set to the value that is being passed if it's a float or an int. And the same below, we're going to use 2 uppercase X to plug the value into, because we're assuming that this value is a child. Okay, so very straightforward and very similar to what we did above. But, okay, we'll see we just have some very fundamental changes and differences to it. And then we are going to return, not the output, but the output uppercase X. Perfect. Okay, simple as that. Again, you could even refactor the code and probably make those both run together. But at the moment, we're going to leave that as it is. What we're going to look at now is essentially have a quick kind of glance over and check we've got everything plugged in, that there is no red kind of showing or highlighted orange, to make sure everything has been plugged in. That's not. Okay, this is just incorrect because it's expecting we need to assign this to something using the left shift operator here, but the way we're using it obviously has changed the functionality of it, so we're no longer using it in that way. So we're actually not checking that is child. That's actually one thing that is wrong. So within check connections attribute, we're going to change that from being check is parent. That is actually what we want to check there. And then we'll actually go down to is parent. What we're actually doing here is checking it the wrong way. I've just realized. So is parent, we actually are not going to get that. We want to return this the other way around. Because if we are a parent, we want to be able to say, okay, well, are there any children? And if the truth is that there are children, then self actually is a parent. So if self has children, then it's a parent. So we'll do self.children. And here we'll do, well, if it is a child, then we should have a parent. So we'll do that around. I've just realized that. So that's my mistake. Perfect. Okay, that's one thing fixed. So we've just navigated to create node name. One thing that we can do to save us doing essentially all of these as uppers, we've got 3 uppers, or sorry, well, we've got 2 uppers, we've got 1 check as upper. We can actually remove one of these. We'll put that in there. We can encapsulate all of this with a tuple, which will essentially still allow us to pass our string through to upper and make sure that our suffix is upper. And now let's scroll down just a little bit to create multi-double linear. Here we go. Create multi-double linear. One thing which I've just realized as well is we don't want that underscore. because we're already going to be using an underscore that is in there. We're only cutting a few items back within the index of the name. And we are essentially then just going to input multi-double linear as this suffix here, which again I suggest you get from a dictionary. Okay, and I've just realized we're actually not returning anything from this function as well. So that's good. We actually need to create, so we're creating this multi-double linear. We do actually want to create it. So let's go to the end and make sure we're at the base level of this function, and then go return multi-double linear dot attribute dot output. Okay, perfect. There we go. Okay, we've done what we need to there. Okay, and press save. And so the last bit that we just have to update with our new functions, with this create plus minus average, most importantly, is that we are giving ourselves the ability to plug in to 1D items, so one-dimensional items. These are multi-index items, and essentially they're kind of like parents in a way, in that they allow you to plug multiple attributes into its children, but they're actually indexed in a different way. They're more like provided to you as a list. So they are not, as children would be, they're not sub-attributes of a dimension, say x, y, z of a scale. These are actually just, this can be an endless list, because we could actually do as many items as we need into the plus minus average node, which actually let's highlight that and press Control J, and then highlight each one of these. Let me just go plus minus average, just shorten the code down a little bit. So what we need to do is we need to give the ability to be able to add to these multi-index items. But let's jump back up and see where we are. So create a plus and minus average. So we see here we've got 3D and input 1D, and this is a plus minus average. Let's jump over to Maya and let's have a quick look at what I'm talking about. Let's open up the node editor within Windows, node editor. And then let's also press tab and copy plus minus average. Okay, and here we go. Here is the node that we're going to be connecting to. So we've got 2D, 3D, 1D. We're using the options for parent attributes 3D, which essentially, if we look in here in 3D, they give us the XYZ as I was talking about, or Z, sorry. But we don't, so we want to use that for parents, but for children, we're plugging into 1D. But if you see in 1D, we have this indexed item. So let me just duplicate this node. And what you'll see here is if we input the indexed item in, we actually get a second index, a third index, fourth index. So you see we're getting this list, this multi-index item of singular kind of points that we can add to. And these can then be sum, subtract, average. So again, really useful and really powerful. But the way that we're connecting, it won't allow us to connect to this multi-index item, because if we jump back to PyCharm, because if we scroll down our code, and actually let's remove the space. I don't know if you did the same that I did, but let's actually clean our code up a little bit. Let's put all the spacing back to being PEP, well, following PEP conventions and PEP aligned. Let's scroll down to our connector node. You'll start remembering the lines of this, where this code all is in the future, trust me. Because essentially you will be able to you'll be able to remember how it's all working. But you see, within our children item, our connect item, sorry, what I was saying. So in the future, you'll be able to remember where your code is a little bit easier, because you'll always know that your code is around about 700. And if you change a few lines, you'll say, it's always at the end, actually. So I go to the end, I've got my delete, disconnect, connect, kind of the important functions here. But our connect item is using self.children to kind of input in. But self.children isn't taking into account anything that isn't just a child item. It's not taking into account multi-index items. So if we go to child, which is a bit further up by parent, here we go. All we're doing is actually listing children out. But the item that we've just looked at with the plus minus average isn't actually a child item. Those are multi-index items. So what we're going to do is we're going to add a little bit of code in that takes into account this. And so what we're going to say is we're going to say if self dot query okay, which is using query attributes. And we are going to go, I believe anyway, let's have a quick check. Or attribute query, sorry, my mistake. And then we're going to pass through some keywords specifically that we need. It's only right above. I could have scrolled. Now life is funny. Okay, so we're going to put in first index matters, because it does. True. Then we're also going to say, well, is this a multi? We want to check whether these items, so we're querying the item and saying, well, is this a multi-attribute item? And we're going to also say again, true. You can shorten these in the future if you want, if you kind of know what they're saying. This is, I believe, I am, and that is just am. But at the moment, we'll just leave them as big full, just because this bit, again, is a bit of more of a kind of an addition and a confusing section, I suppose, if you're looking at it with new eyes. But we are, in most circumstances, we're just going to be returning whether it's a child or a parent with this, okay? Or sorry, if there are any listed children. But we also want to be able to grab any listed sub-items that are multi-index. So that's what we're going to do here. We're going to return one thing here, which is just the children. And here we're going to return the children of a multi-index item. So let's go through and write the rest of this code. Okay, perfect. So we've got our original code, and now we've got our new code. And we have confirmed that this is a multi-index item to start with. So the first thing that we're going to do is we're going to get the we're going to get the indexes of any items that have already been plugged in, or try and count how many there are. So we're going to try and essentially say within 1D, which is self here, we're going to pass through and we're going to say, well, how many multi-indices do you have? And at the minute, because it maybe if it's just been created, it'll actually be 0. It'll return none. So this will actually annoyingly just return nothing because there's nothing there. So we say, well, if none, okay, well, if there is some, so if it's not 0 or if it's 1, then we essentially go through and then we list them out. How many are there? Okay, we're going to say what's the length. And else, we're going to say 1. The item we know to use then is 0. If this returns none, because there are none, then we're going for the first index. And that's how the kind of logic we're essentially using here. And then we're going to go list children, self query list children, true. And then if there are children, so if there essentially are, if 0 has been plugged in or if 1 is there, okay, then we are essentially going to return, okay, from a multi-index item, which it would be a multi-index item of a 3D perimeter, we're going to return this with string append. We're going self .node .attribute, and we're then going to do a string append within our get item, because this is going to be a bit of a different one. We're actually using the attribute name and then the index point. So let's jump back to Maya. And so what we did here in our script editor was we plugged into the output 1D at index 0. Okay, and then we plugged into 1D index 1 and then 2. So we actually plugged in to each one of those items. Now let's jump back to Maya. So that would be, again, if this is not a item with a child, this is just the 1D. So we're just going to go, well, the attribute name and then that attribute's index within there. Okay, so returning a single multi-index item or returning a multi-index item. Okay, if it has children. Okay, so we're taking now into consideration multi-index items here. And if it's not, then we'll just skip all that code and it'll go straight to the default that we're doing down here. But okay, that is essentially taking care of that situation. Okay, I think that is essentially everything that we need to look at. Oh, actually, oh my lord, I think I've just forgotten one big bit. We have not filled in our divide and our power. Now, these will be quite quick because they are just using the multiply divide. Now, let's literally just copy this code down for each. So Control Shift Alt, put your cursor in, and then press Control V, and then Enter, just to give us a space on the line. And we've, for some weird reason, it does keep on just indexing or putting everything in the worst spot. So I've just gone, I put the cursor in, I've done then Control Shift and arrow left, and I'm just going to go Enter, put everything back in the right place. So now we've got our divide and true divide. and power. And I'll explain what these are in a minute, but let's just say these are both divide. And we are just going to quickly go in and append all the doc strings. Okay, perfect. So what we've done is we've essentially used our multiply divide node again within these division, true, and power. And what we're doing is we're just changing the operation type because we're going to connect them in exactly the same way, but we're just setting the operation to be different because we want essentially a multiply, divide, or power. Well, that was further down than I expected. Okay, but let's have a little look at the difference between divide and true divide. In Python, divide and true divide, they're used for implementing division, but they behave slightly differently depending on the version of Python that you're using. Divide was used for division in Python 2. And with true divide being brought in I think 2.2 or maybe 2.3. But so what essentially it makes true divide essentially is the default for Python 3, I should say. So essentially we're having these two division methods in here will make us back compatible for Python 2, which is quite useful. They do behave a little bit differently with the way that they interact. True divide always uses essentially a floating point division. So it'll just be a little bit different. But then regardless of the type, essentially, it'll always just give you that floating point division. From anything else, let me think. I'm trying to think. In Python 3, you can override the custom behavior of true div, but I don't think there'll be any real need to. Because again, all the information you're going to be pointing through, essentially, if you're using these with nodes, you're always going to be passing through essentially either an int or a floating point number, which will then give you the output that you need from the node. So we don't really have to worry about that too much. But that is the implementation there. Okay, perfect. So now we have all of our operators set up, and we now can do all of these functionalities in a Pythonic way and create the nodes straight within Maya. So that's pretty awesome. We're going to go ahead in the next module and start writing some tests and try to make sure that all of this is working, and that we can also kind of help it be a little bit more understandable for ourselves. So we'll get on with that in the next lecture.